This is a short video on how to multiply and divide complex numbers that are in polar form already. Now, if they're already complex numbers, you can multiply them much quicker than what I'm going to show you here. But if they're in polar form, there's actually an easier way, and it kind of leads into how to take powers and how to take roots of these complex numbers, which can only be done from the polar form. Alright, so this is going to use Euler's formula. So we're going to change both of these into the modulus, which happens to be 2. E2, the argument in the first case, Z1 here, is pi over 4. And then it would be pi over 4 I. It's a weird thing to have in a power, but that's Euler's formula. He's proven that e to the I theta is the same thing as cosine theta plus I sine theta. It's a neat kind of formula, and it'll make our work a little bit easier. Alright, Z2 here then would also be 2 modulus e raised to the argument of, oops, that's supposed to be negative, negative pi over 6, and then the I. Now technically you could put the I in front or back. I usually just put it in the back. Alright, so if we're going to multiply these two, we're going to multiply them by their Euler formulas. Euler, by the way, is spelled this way. Very famous mathematician. It's not pronounced Euler, it's Euler. So if I do Z1 times Z2, then I get 2 times e to the pi over 4I times 2 times e to the negative pi over 6I. Alright, so then the ideas of powers are going to kick in. So let's get the 2 times 2 out of the way. That becomes 4. And we're going to have e to the pi over 4I times e to the negative pi over 6I. And the laws of exponents say as long as your bases are exactly the same and you're multiplying them, then all you have to do is add the exponents. So off to the side, all I have to figure out is what's pi over 4I plus a negative pi over 6I. So they have a common I term, so we can add them together. They just need a common denominator. So this one will be 3 pi over 12 minus 2 pi over 12, that are known as just a single pi over 12. So the power is going to become pi over 12I. So the modulus of this new number would be 4 e to the pi over 12I. Okay, so then all we have to do is back out of Euler's formula and go back to regular old polar form of a complex number. And we're going to get 4 times cosine of that angle, pi over 12, plus I sine of that angle, pi over 12, would be the product of Z1 times Z2. Alright, so we can type this into a calculator and find out what this new complex number is. So I have to make sure my calculator is in radians. So mode, radian, alright. So we're going to go 4 times cosine of pi over 12 is 3.86. So this would be 3.86. And then sine of 4 times sine of pi over 12 is 1.04. So this would be plus 1.04i. And that would be the product of these two complex numbers up here. And you can convert these also into decimal format, multiply them together the old-fashioned way with FOIL, and the answer should come out exactly like this. Alright, let's look at division now. So what if I want to find, let's go backwards, Z2 divided by Z1? Well, the same thing's going to apply. We're just going to write them in Euler formula. So we're going to go Z2, which is this one, e to the negative pi over 6, I, over 2e to the pi over 4i, the z1. And we're just going to divide. So here when we divide, the modulus goes away, we get 1. When we get to the powers, when you divide common bases, you subtract your powers. So that's going to become negative pi over 6 minus pi over 4, which is going to be negative 2 pi over 12 minus 3 pi over 12, better known as negative 5 pi over 12. Alright, so then we just back it out of, it'll be e to the negative 5 pi over 12i, and we're going to have a modulus of 1, so this answer is going to be cosine of negative 5 pi over 12 plus I sine of 5 pi over 12. Negative 5 pi over 12. Oh, and I forgot the I. Sine. Alright, and then we can just type it in. Cosine of negative 5 pi divided by 12 would be 0.26. And sine of the same angle, since there's no modulus, is 0.97, and it'll be negative. So it'll be negative 0.97 I. And that would be the quotient of Z1 and Z2. So it's kind of a neat trick to change it into Euler's formula. Euler tells you what to do with your angles, and then all you have to do is plug it back into polar form.